sometimes you get an equation that's what we call reducible to a quadratic. So it may not be a quadratic, but there's a way to change it so it is a quadratic. So here we have an example up here where we have x to the fourth plus 3 equals 4x squared. Now, this is not a quadratic. This is a quartic because the highest power we have is x to the fourth. Okay, so it's not. But if we also notice that we only have even powers of x, so we can make what we call a substitution here. So instead of writing it the way it is, we change the variable. Okay. So instead of writing in terms of x, I'm going to write it in terms of y. And I'm going to set x squared equal to y. And so then, when we square both sides of this, we get x to the fourth equals y squared. So by making this substitution, which may seem arbitrary, we are able to change this equation. So x squared is equal to y, and x to the fourth is equal to y squared. So every place there's an x squared, I can write y. And every place there's x to the fourth, I can write y squared. So this will be y squared plus 3 is equal to 4y. So now this wasn't a quadratic, but this is. So now we can solve this equation. So subtracting the 4y, we get y squared minus 4y plus 3 is equal to 0, which factors as y minus 3, y minus 1 equals 0. Now solving for y, we get y equals 1 or y equals 3. So we've got a solution to this quadratic, which we can then go back now and use to help solve this quartic. So we know y equals 1 or 3. So this equation now gives us two things. It tells us, so y is equal to 1 or 3, so we know x squared is equal to 1, or x squared is equal to 3. So solving for x now, we get that x is equal to plus or minus the square root of 1, which is plus or minus 1. And on the other hand, we take the square root here, we get x equals plus or minus the square root of 3, which we can't do anything with. So this equation can be reduced to a quadratic, and in the end, we get these four answers. -1, 1, negative square root of 3, positive square root of 3.